Okay, number 20, and this is another word problem. A business executive travels 1,120 miles in a corporate jet and then travels an additional 60 miles by car. The plane ride took 2 hours longer than the car ride, and the jet travels 8 times the speed of the car. Find the total time for the 1,180 mile trip. Right, so yeah, the trip was 1,120 miles plus another 60 miles, so that's 1,180. That makes sense. But yeah, this is not an easy problem, right? Because there's a lot of things we don't know here, right? What we're looking for is the total time, right, for the entire trip, and that's jet and car, right? But we don't know how long it took for the jet ride, and we don't know how long it took for the plane ride. So why don't we just give those names? So let T for time, but we have the time for the jet, the time for the jet trip, and let's say TC, this is the time for the car ride. Right. We also don't know the speed of the jet. So let's just call that J. So this is the speed of the jet. The average speed, right? Close enough. And then C will be the speed of the car. Sorry. Speed of the car. All right. Okay. And notice we're looking for the total time. Well, that's basically just the time for the jet plus the time for the car, right? So times just add. So this is just going to be TJ plus TC. Right now we don't know either, but if we know both, we just add them up and that gives you the total time. And that's what they're asking for. All right. What else do we know? Well, we know the plane ride took 2 hours longer than the car ride. Okay. So that tells me the time for the plane was longer than the time for the car. So the time for the plane, the jet, right, was the time for the car plus an additional 2 hours, right? Okay. So in fact, these are related, right? If you know the time for the car, you know the time for the jet. Right? So the time for the jet is the car time plus 2, and then the total time adds another car time. So that's just 2TC plus 2. So now all we need is the time for the car. If we know the time for the car, right, we just multiply that by 2 and then add another 2. So that's the total time. Right. What else do we know? We know that the jet travels 8 times the speed of the car. Right, so that's the speed of the jet. Right? The speed of the jet is just 8 times the speed of the car. Right? Which is not 8 plus c. Right? That would be 8 miles per hour faster than the car. It's 8 times, right? Multiply. 8 times c is the speed of the jet. Okay, so yeah, so we don't need a j anymore. We can just use 8 times c as the speed of the jet. Okay, so now let's just put this all together. Let's just make our usual table here. And the usual 2 rows, 3 columns. Right? The columns are, right, speed times time equals distance. Right? Now notice there's no wind, so we're not going back and forth. This is a one-way trip, right? So the 2 rows then are just for the jet, one for the jet and one for the car. Right? And we know the speed of the jet is j, although we don't need that anymore because the speed of the jet is just 8 times the speed of the car. So 8 times c. right? The time for the jet, what we call TJ, but that's really just the time for the car plus 2. So at this stage, right, I'm not going to use TC, I'll just use T, because that's the time for the car. So car time. Okay, and the distance for the jet, I forgot. It was 1,120 miles, right? 1120. Right, what about the car? The speed of the car, that's just c. The time for the car, that's tc, or just t, right? And the distance for the car, yeah, 60 miles. Okay. So I think these are the two equations, right? Speed times time, so 8 times c times time, t plus 2, is equal to 1120. That's the first equation. The second equation is c times t equals 60. Okay, so we have two equations. However, we also have two variables. Okay, so I'm just going to copy down the first equation here. And I think we'll just multiply it out, right? Distribute the 8c. So we have 8ct plus 8c times 2, that's 16 times c, is equal to 1120. So notice something very familiar here, this c times t. We know what that is. C times t is just equal to 60. So I can replace ct with the number 60. Right, so this is going to be 8 times 60 plus 16 times c equals 1120. 8 times 60 is 480 plus 16c equals 1120. So let's take away the 480 from both sides. And that's 640. 640. And if we divide by 16, 640 divided by 16 is just 40. Oops. So that's equal to 40. So that's C, right? C is 40. What was C? C is the speed of the car. So that must be 40 miles per hour. Miles per hour. But that wasn't the question, was it? The question was to find the time, not the speed. Right? However, notice that c times t is equal to 60. And now we know what c is. It's just 40. So now we know what t is. Right? Divide by 40. So t is just 60 over 40, which reduces to 6 over 4, which reduces to 3 over 2. Or if you prefer, 1.5, right? 1.5 hours. So what is t? Little t is the car time. So the car ride took 1.5 hours. 1.5 hours, right? Right. How long for the jet ride? The jet trip took t plus 2. So that's, so the jet trip took t plus 2. So that's 1.5 plus 2. So that's 3.5 hours, right? So the jet ride took a total of 3.5 hours. The car ride took 1.5 hours. So the total time for the whole trip is the car time, 1.5 hours, plus the jet time, 3.5 hours. I think that's 5 hours. So that's the answer to this question, which admittedly, confusing question and not an easy one, but that's how to do it. Right? So yeah, so this, I would say, for a test, this would be a very challenging question for a test. And if you got it, then I would say that the test will probably be a lot easier than this. All right, so that's number 20. Okay, number 21. Part A, we want to solve for g, and the equation is m equals r plus v over g. Right. So these are still rational equations. They're equations that involve fractions, right? What are we looking for here? We're looking for g. We're looking for g, this variable, so it's in the denominator. Right? So the usual way is to multiply both sides by the least common denominator. Well, there's only one denominator, so I'm just going to multiply both sides by g. So on the left and on the right. Okay, so on the left we just get gm. On the right we get g times r, right, plus g times v divided by g. So by multiplying both sides by g, we end up canceling the g in the denominator, right? So what do I have now? I have gm equals gr plus v. And we're looking for g, so I would get all the g's on the same side. How about if I subtract gr from both sides? Right. So on the left we get gm minus gr, and that's still equal to 0 plus v. All right. Now we have a g here and a g here. What's our common factor? Our GCF is just g. So factor that out. It's g times m minus r, and that's still equal to v. Now we can divide both sides by just m minus r. And there we go, right? So cancel the m minus r's. G is equal to v over m minus r. Right. Now, some of you might have done this a little bit differently, and that's okay. Oh, sorry, I'm leading the witness here. So m equals r plus v over g. Right. So the other way to do it is, let's just subtract the r from both sides, right? So m minus r is equal to v over g. But this is a proportion, right? You have a fraction on the left, right? M minus r over 1. I mean, yes, it's two terms, m minus r, but it is a single fraction, right? For example, it's not, d plus m minus r over 1. Or I should say like d over 3 plus m minus r over 1, right? This would be two fractions. This is one fraction. So the point is we can just cross multiply here, right? Multiply m minus r, right, in parentheses, times g, and that's equal to 1 times v. Right? So now just divide by m minus r on both sides. So cancel the m minus r's, and there's our g. G is equal to v over m minus r. Right. Same answer we got the other way, which was a little bit longer, but it works, right? So that's 21a. 21b, very similar. Right. So we have c equals 3a over a minus b, and we want to solve for a. Okay, so this is a proportion, right? If it helps, the left side is really just c over 1, and the right side is 3a over a minus b. So cross multiply, right? Multiply c times a minus b. Don't forget the parentheses, right? Because if you just write ca minus b, you're multiplying the c times the a, but not the b. That would be wrong. And the right side is just 1 times 3a, or just 3a. Okay, we're solving for a. Now we can distribute the c here, right? So we have c times a minus c times b is equal to 3a. Keep in mind we're solving for a, right? So I want to get this a and this a on the same side. I guess I can do that by subtracting ca from both sides. So I get 0 minus cb on the left and 3a minus ca on the right. All right, negative cb equals 3a minus ca. And again, if you want the a on the left, if that looks backwards, just switch sides. Right? And now what's our GCF here is just a. So factor out the a, and then divide by 3 minus c. Right? So that cancels, and so a is equal to negative c times b, that's a b, divided by 3 minus c. And that's not the answer in the back. The answer in the back is BC over C minus 3. And I will leave it to you to convince yourself that these are the same answers. So either way, it's correct, right? All right. As a hint, notice where the negative sign is. It's in, right, it's in front, but you can just bring it downstairs. In other words, if you have a negative fraction, say negative 3 over 5, you can write that as negative 3 divided by 5 or 3 divided by negative 5. So this is negative, and right, there's no negative in the second fraction. It's a positive. So I just brought the negative down and distributed the negative, and you get negative 3 plus c or c minus 3. Right. All right, number 22. Okay, so for number 22, we want to simplify the complex rational expressions. Please don't get confused with, imaginary, right? There's no i's here. So the word complex just means, complicated, right? Has nothing to do with imaginary or complex numbers, right? Which is why I like to call these compound fractions rather than complex. Either way, we have to simplify them, right? And there's two ways of doing it. For lack of a better term, we just called them method 1 and method 2. And I can never remember which is which. But when you look at part A, what should be familiar to you here is just the fact that the numerator is a single fraction and the denominator is a single fraction. And fractions are just divisions, right? So we can think of this as 6x cubed over x minus 2 divided by 4x over x squared minus 4. And we did these already a long time ago, but we did them. How do you divide fractions? You multiply by the reciprocal. So keep the first fraction, change this to multiply, and then just flip the second fraction over. Okay. And now just simplify, right? Factor and cancel. Well, the 6 is 2 times 3. We'll factor the numbers as well. And x cubed is x times x squared. Right? X minus 2 is prime. It's just x minus 2. And x squared minus 4 can factor as x minus 2 times x plus 2. Right? A squared minus b squared. And then the denominator here, 4x, is 2 times 2 times x. Right? So everything's factored completely. Now we just cancel. We can cancel a 2. We can cancel an x. And we can cancel x minus 2. And I think that leaves us with 3x squared times x plus 2 over 2. It's just a single 2 in the denominator. Right. And I guess we'll just leave it like that. Okay, in part B, we want to simplify 1 over x minus 2 over x squared. All of that over 1 plus 4 over x. All right, so the one thing you don't want to do, you don't want to do this the same way as the previous problem. And that's because the numerator is not a single fraction. It's 2 fractions, right? And the denominator is also 2 fractions, right? So if you're doing this, you're doing the wrong thing here. Right? I mean, you could do it this way, but you have to subtract these and you have to add these. You know how to do it. It's not hard, but it's a lot of work, right? So yeah, I generally don't want to do it that way. So here's what I would do, right? This is the numerator, and this is the denominator, which I can write as 1 over 1, right, instead of 1. So if I just multiply numerator and denominator by the LCD, okay, what's the LCD here? So we have an x, a 1, an x squared, and an x. So it's just 1x squared, right? Use the biggest exponent. Oops, LCD. So the LCD out of all these denominators here is just x squared. So if I multiply top and bottom by x squared, right? I'm just multiplying by 1. I could cancel these. That would be bad. But be careful you don't do, top and bottom here, right? It's just x squared over x squared, not x squared over x squared over x squared over x squared, right? So now just distribute the x squared to each of these terms. And what do we get? We get x squared over x minus 2x squared over x squared. And then all that over x squared over 1 plus 4x squared over x. And if the thought occurred to you that this is not simplifying, because this looks worse, it does, right? This is worse right now. But look what you can do here, right? X squared divided by x, that's just x, right? 2x squared divided by x squared, the x squares cancel, so that's just 2, right? Or negative 2. Right? X squared over 1 is just x squared, and 4x squared over x is just 4x. Right? And now, just simplify, right? Factor and cancel. The numerator, x minus 2, there's nothing to factor there. It's prime. The denominator, we can factor out an x, and we're left with x times x plus 4. So we're factored completely. What can we cancel? Right, nothing, right? So this is it. This is as simple as it gets. We're done. Right? So this is the other method, and you would have gotten the same thing if you did it the other way, at least you should have, but I find that to be a little more confusing. So I like this way better. Right? And part C is a real challenge. But okay, let's try it. 3x, okay, so I'm not going to read it to you. You can see it yourself. I think I copied it down correctly. Just make sure of that. All right, so first of all, what's our LCD here? Our LCD has to include this x minus y, same as this, right? And it also has to include x plus y. So it's just going to be x minus y times x plus y, right? Which is x squared minus y squared, but let's not do that just yet, right? Right. So our goal here is to multiply this numerator, right, and all of these denominators here, right, by the LCD, which is x minus y times x plus y over 1. And then the same thing in the denominator, x minus y times x plus y over 1. Okay. And again, you get a mess, but the mess for the numerator is 3x plus y times x minus y times x plus y all over x minus y. And now you can see why we did that. We're going to cancel the x minus y's, right? What about the denominator? The denominator, so here we have to be a little more careful. We have to distribute this, right? So 2 times x minus y times x plus y all over 1 times x minus y plus 1 times x minus y times x plus y. That's a y, sorry. All over x plus y. So why did we do that? So we can cancel this x minus y here, and then these x plus y's here. Okay, so now all the denominators are gone. Well, we still have this denominator, the big denominator, and then the big numerator. So the big numerator is 3x plus y times x plus y. And then the big denominator is 2 times x plus y plus x minus y. So I'm not going to multiply out the numerator. I'm going to leave it as 3x plus y times x plus y. Now, in the denominator, we don't have a choice. We're going to have to add these terms. So we get 2x plus 2y plus x minus y. Okay, so 2x plus x is 3x, and 2y minus y is y. Well, this is nice because the denominator is just 3x plus y, and we have the same factor in the numerator, right? So that just cancels. Excuse me. And we're left with x plus y over 1. But dividing by 1 doesn't do anything. It's just x plus y. Okay, so that's the answer for 22C. All of this mess here, when you simplify it, this is really just x plus y. Okay, number 23. These are probably going to be the easiest ones you can get on a test. So we're given a function, f of x is 5x minus 11, and we want to evaluate the function at negative 4. The only tricky thing about this is that you want to make sure you understand this notation. This is not f times negative 4. Right? You're not multiplying. Right? F is just the name of the function. Okay? All it means is substitution, right? Wherever you see an x, change it to the number negative 4. So instead of 5 times x minus 11, it's 5 times negative 4 minus 11. So that's negative 20 minus 11, negative 31. And that's the answer to part A. Right? So part B, f of 0, is just 5 times 0 minus 11, or negative 11. For part C, f of 2/3 is 5 times 2 over 3 minus 11. All right, so this one's a little bit more difficult to work out. You have 5 times 2 is 10. 1 times 3 is 3. But now we need a common denominator, which is just 3. So multiply top and bottom by 3 here. So you get 10 over 3 minus 33 over 3. So that's going to be negative 23 over 3. You can leave it like that. And part D, well, I shouldn't have to do this, right? It's just 5 times 5 minus 11. So 25 minus 11 is 14. Okay, so I think that's it for number 23. Okay, so for number 24, we have a different function. We have a rational function, x plus 3 over 3x minus 1. And again, we're just evaluating the function at different values of x. In this case, negative 1. So replace all the x's with negative 1, not just the one in the numerator, the one in the denominator also. So negative 1 plus 3 is 2, and negative 3 minus 1 is negative 4. But that reduces to negative 1/2. Right. For part B, g of 0, so this is going to be 0 plus 3 over 3 times 0 minus 1. So that's just 3 over negative 1, or negative 3. For part C, g of 7, well, 7 plus 3 over 3 times 7 minus 1. 7 plus 3 is 10. 7 times 3 is 21, and 21 minus 1 is 20. So 10 over 20 is 1/2, right? Positive 1/2. And finally, part D, I'm going to do this over here on the right, g of 1/3. So replace all the x's with 1/3. 1/3 plus 3 over 3 times 1/3 minus 1. So 1/3 plus 3 is 10 over 3. The denominator 3 divided by 3, right, is 1, and 1 minus 1 is 0. So we get 10 over 3 divided by 0, but that's not a number, right? That's undefined. So g of 1/3 is undefined, right? There's no answer there. Right? And the reason is because, well, what's the restricted value? When is 3x minus 1 equal to 0? Right, when x is 1/3. So 1/3 is a restricted value. We shouldn't have plugged it in the first place. It wasn't allowed into the function. Right? Or, put another way, if you do plug it in, you get nonsense. You get nothing. Right? Not 0, you get undefined. It's not a number. Okay. Right. In 25, we want to find the lengths of the two legs of the following right triangle. So the shortest side here has length x. Then we have another side with length x plus 7, and then the hypotenuse is 17. Okay, so you should know the relationship between the three sides, right? We usually call these, right, A, B, and C. And then by the Pythagorean theorem, a squared plus b squared equals c squared. So, yep, you have to know the Pythagorean theorem. We talked about it a couple of times already, right? So replace a with x, so you just get x squared. Replace b with x plus 7. Sorry, x plus 7. And don't forget you have to square that. And replace c with just the number 17. So multiplying this out now, you're just going to get x squared plus 14x plus 49 equals 17 squared 289. Okay. So this is going to be a quadratic equation, right? X squared plus x squared is 2x squared plus 14x plus 49 minus 289. Right, so take away the 289 from both sides. And I think that's going to be negative 240. Sorry. So 2x squared plus 14x minus 240 equals 0. So before you go plugging these numbers into the quadratic formula, notice you can divide everything here by 2. So you're going to get x squared plus 7x minus 120 equals 0. Right. Now, if you want to plug these numbers, a is 1, b is 7, c is negative 120, into the quadratic formula, go right ahead. But notice that this is also factorable. As x plus 15 times x minus 8, right? So 15 times negative 8 is negative 120, and 15 minus 8 is 7. So x is either negative 15 or positive 8. Yep. Lengths are not negative. The length of a triangle doesn't make sense, right, for this to be negative 15, feet, or negative 15 centimeters, or negative 15 miles, right? So distances are positive. So x equals 8, right? So what does that mean for the legs of the triangle? Well, one of them is clearly 8, right? And the other is, well, 8 plus 7, which is 15, right? But not negative 15, positive 15. So, yeah, that answers the question. The lengths of the two legs are 8 and 15. And notice I didn't give units here, so it doesn't matter whether it's, miles or inches or feet, right? So 8 and 15. Okay, and we get another word problem. They're sprinkled throughout the practice test here. We have a mixture of a 15% disinfectant solution is to be made from a 12% solution and a 20% solution. How much of each is needed to get 32 liters of a 15% mixture, right? So we're looking for the number of liters, the volume, or the amount of each solution, right? So let x be the amount of the 12% solution, and let y be the amount of the 20% solution. Right. Right. And now we just make our usual table. So here we have, right, so we have the solution, and what's in the solution is the disinfectant. So those are the rows, right? And then we have the percentages, right? We have the 12% solution, we have the 20% solution, and when we mix them together, right, we don't get 32%, right? We get a 15% solution. This is the mixture, right? So the amount of the 12% solution, we don't know what that is. We'll call that x. The amount of the 20% is y. And the amount of the 15% mixture, that's given in the problem, right? That's 32 liters. So that's 32. Make that clearer. 32. Okay. What about the disinfectants? Well, from the 12% solution, only 12% of the x liters is disinfectant. As a decimal, 0.12 times x, right? And then 20% of the other solution, so 0.2 times y. And then for the mixture, it's 0.15, 15% of 32. And I don't think I can do that in my head, so 15% of 32, I get 4.8. So this is really just 4.8, right? So these are our two equations, x plus y equals 32, and 0.12x plus 0.2y equals 4.8. So I'm assuming you can take it from here. You solve that system of equations, and you can find x and y, and that answers the question. Okay, so I'm going to do this very quickly. Just multiply the bottom equation by 100. Oh, you could get away with less, but let's do 100. So the first equation is just x plus y equals 32. The bottom equation is 12x plus 20y is equal to 480. And if you multiply the top equation by negative 12, you get negative 12x minus 12y equals negative 384. And we can leave the bottom equation alone because we're just going to add them together. We're going to eliminate x. So we get 0x plus 8y equals 96. And 96 divided by 8 is 12. So y is 12. 12 liters, right? You can abbreviate. So that's the amount of the 20% solution. What about the 12%? Well, right, we know that x plus y equals 32. So if y is 12, oops, 32, then just take away 12 from both sides and you get x equals 20. So, yep, we have 20 liters of the 12% solution. And when we mix that with 12 liters of the 20% solution, we get 32 liters. And you can check that it's 15% solution, right? Okay, so that's 26. Number 27, Jesse can build a front porch in 10 hours. With Grecia's help, they can build a porch in 6 hours. How long would it take Grecia to build a porch working alone? So what should we call it? T for time, maybe G. So let G be the amount of time Garcia works alone. Okay, so another table here, usual. Right, so this is going to be rate of work, right? So rate times time equals the amount of work you get done. So, in other words, the fraction of the porch that gets built. So fraction of porch. Right, so we have Jesse and Garcia. So the rate for Jesse, well, Jesse can build the entire porch alone in 10 hours. So in 1 hour, Garcia builds 1/10 of the porch. The amount of time, well, we don't know. We don't know that yet. The amount of work, I'm sorry. We do know the amount of time. The amount of time they work together is given, right? That's the 6 hours up here. Okay, so they both work together for 6 hours. Okay, so the amount of work that Jesse does is 6/10, or 3/5. For Garcia, we don't know what Garcia's time is, but the rate is just 1 over the time, right? Just as it was for Jesse. So the time, again, they work together for 6 hours. So 6 divided by G, make sure these don't look alike. That's the amount of work that Garcia does. When they work together, what happens? They build 1 porch. So when you add these up, your equation is 3/5 plus 6/G, I should have called it T, right, is equal to 1. Okay, so all you have to do is solve this for G. Right, and there's a lot of ways of doing it. Right. So the way I'm going to do it is just take away the 3/5 from each side. So 6 divided by G is equal to 5/5 minus 3/5, which is 2/5. And now I have a proportion, right? So 2 times G is equal to 6 times 5. And 6 times 5 is 30. And 30 divided by 2 is 15. So there's our answer, 15 hours. So that's how long it would take Garcia working alone. It's a long time, right? But again, working together, they can do it in 6 hours. So, all right. And 28. So we have another word problem. The speed v. So the reason why we typically use the letter v for speed is really v stands for velocity, and a lot of people get them mixed up, speed and velocity. In this class, it's the same thing. When you get to higher level math classes or a physics class, they will distinguish speed and velocity are not necessarily the same thing. But in many cases, and in this case they are. So that's why we use v for velocity. It's also speed. So the speed in meters per second of water pouring out of a hole at the bottom of a cylindrical tank is given by this formula. So v is equal to, it's a funny looking v, there you go, v is equal to the square root of 20 times h plus 8. H is the height of the water in the tank. If the speed of the water is measured at 6 meters per second, find the height of the water. So they're telling us the speed is equal to 6. That means this is equal to 6. So there's your equation. Just solve that equation. Okay. So even though it's a word problem, it's It's kind of just a clunky word problem, but it's really just asking you to solve this equation, right, for h. That's the height of the water in the tank. Right? Okay, so yep, first thing I would do is just get rid of the square root, square both sides. So you're going to get 20 times h plus 8 is equal to 6 squared. 6 times 6 is 36. Right. Take away the 8. And 36 minus 8 is 28. So now divide by 20. And h is going to be 28 over 20, which reduces to, let's see, 4 times 7 over 4 times 5, right? So 7 over 5, or if you prefer, 1.4. And this is in meters, so 7 over 5 meters or 1.4 meters. And that's the height of the water in the tank. So that's 28.